This is the formula for a large molecule, but don't let that deter you. It's really just symbols and numbers, and you can handle both. Actually, following a deep breath, this one's pretty straightforward. Take it one element at a time, remembering that the count is denoted by the subscript following the symbol. That means there are 63 carbon atoms, 88 hydrogen atoms, 14 nitrogen atoms, 14 oxygen atoms, one single cobalt atom, and one single phosphorus atom. Organic compounds are extra fun to work with, in part because lots of times the same type and number of atoms can lead to different compounds with very different properties. To more clearly indicate how the atoms are actually strung together, a condensed structure, such as this one, is used by the chemist. We'll learn to determine the bonding from this formula later in the term, but for now we just have to read it. This looks wonky, but really it's just 3 types of atoms. You can even rewrite your formula to better show that if it helps you. Note that to move from the condensed formula, or that first formula you were given, to this more generic formula, I just added the subscripts for the elements. A single carbon in 2 different places in the condensed formula becomes 2 carbons in our second formula. Similar story for the hydrogen atoms. 3 plus 2 plus 1 equals 6. Now that we've simplified the formula, we can work on a count. The subscript 2 behind the symbol for carbon means that there are 2 carbon atoms. The 6 following the symbol for hydrogen means that there are 6 hydrogen atoms. And the implied 1 behind the oxygen means that there is a single oxygen atom. This is the difficult one of the bunch. The PO4 that you see in parentheses is another polyatomic ion called the phosphate ion. The phosphorus and those 4 oxygen atoms were playing in their own little sandbox, happily sharing a charge amongst themselves. A second group of 1 phosphorus and 4 oxygen atoms were playing in another corner of the same sandbox. Along came a calcium ion, or 3, of opposite charge, and then everyone started playing together. But the phosphate groups were their own thing initially, and we denote that using those parentheses. The count for calcium hasn't changed from what we've done before. Read the subscript to determine that there are 3 calcium ions. It's okay if you called them atoms for now, but know that that isn't the correct term, but more later. There are 2 phosphate groups. Each group contains 1 phosphorus atom and 4 oxygen atoms. 2 times 1 gives you 2 total phosphorus atoms, and 2 times 4 gives you 8 total oxygen atoms. These counts come from distributing the subscript on the outside of the parentheses to everything inside of them.